All right, we're going to start with looking ahead 7, using the GCF to factor polynomials. Sometimes you know the product and are asked to find the factors. This process is called factoring. A polynomial is in factored form when it is expressed as the product of polynomials. So what we've been doing before was multiplying two polynomials, whether that was multiplying a monomial times a binomial or multiplying two binomials, and then we'd end up with a single polynomial when we are finished. What we're going to do now is take that polynomial and work backwards and rewrite it so that it's in factored form, so that we can see what two things would have been multiplied to get that polynomial. So one of the ways we can do that is using the GCF. Factoring using the GCF, or the greatest common factor, is basically using the distributive property in reverse. For example, to factor 8x squared plus 10x, we would first find the GCF of both terms. So the greatest factor that is common to both terms here. So let's first look at the two numbers, 8 and 10. Well, I know for sure that they're both even, so 2 goes into both of them. And since 2 goes into 8 4 times, and 2 goes into 10 5 times, 4 and 5 don't have any further common factors, so 2 would be the largest number that goes into both of those. And then let's look at the variables, x squared and x. Well, the greatest thing that is common to both is x, because even though there's an x squared here, there's only x here. There's more x's here than there are here. So only one x that's common to both. So this is the greatest common factor. So now we use the distributive property to rewrite each term. So we are factoring out 2x, that's the greatest common factor of both terms. And then in the parentheses, we want something that we can multiply this 2x by, two things, that will give us 8x squared plus 10x. So if I want to know what I multiply 2x by to get 8x squared, what I'm doing in my mind is actually dividing these. So 8 divided by 2 is 4, x squared divided by x is x. And I can always double check this. 2 times 4 is 8, x times x is x squared. Okay, and then for the 10x, what do I multiply 2x by to get 10x? Well, the x's are the same, so really what do I multiply 2 by to get 10? And that, of course, is 5. 2x times 5 is 10x. So now this is in factored form. I can see that this polynomial here has one factor of 2x and another factor of 4x plus 5. And those two things, when multiplied, give me that original polynomial, 8x squared plus 10x. All right, so let's try 3 examples of factoring using the greatest common factor. Okay, so between 3x and 9, I know that the largest number that goes into both of these is 3. And then the 9 doesn't have a variable at all, so that's actually the greatest common factor of both of them. Now, what do you multiply 3 by to get 3x? Well, just the x. And what do you multiply 3 by to get 9? 3. So 3 times x is 3x, 3 times 3 is 9. One factor is 3, one factor is x plus 3. Okay, x squared plus 5x, greatest common factor between these. Let's see, there are no numbers in common between them other than 1. And then the variables, the greatest number of x's in common to both terms is just a single x. So the greatest common factor is just x. Now what do we multiply x by to get x squared? That would be x. And what do we multiply x by to get 5x? That would be 5. X times x is x squared. X times 5 is 5x. Okay, here we have 3 terms. So let's find the greatest common factor of the 3. So we have 18, 12, and 6. And I know that 6 goes into all 3 of these. So we have 6. And then for the x's, let's see, there's 2 here, but then only 1 here and 1 there. So only a single x that's common to all 3 terms. And then y, we have a single y here, 2 of them here, and 1 there. So again, only 1 that's common to all 3. All right, so to get 18x squared y, I would have to multiply 6 times 3 to get 18. I'd have to multiply x times x to get x squared, and nothing to multiply y by to get y because I already have y. Okay, for the next term, 6 times 2 will give me 12. X is already there, and then y times y to get y squared. And this last term, we see this is the same as this, so if I want to get the same thing back, I would have to multiply it by 1. 6xy times 1 is 6xy. Okay, so there are some try-it-yourself problems at the bottom of this page. Go ahead and pause the video, work through those 3 problems, and when you're ready to check your answers, press play. Okay, for A, you should have 2 times 2x plus 5. And then for B, x times 3x plus 4. And for C, 5ab times 3b minus 5c. Okay, so that's it for factoring with the GCF. Let's move on to factoring trinomials. So we're going to look just specifically at a very special type of trinomials that are actually much easier to factor than other trinomials, which you'll see in Algebra 1 next year. A trinomial is a polynomial with 3 terms. Just like we saw a monomial has 1 term, a binomial has 2 terms, a trinomial has 3 terms. Trinomials that are in the form x squared plus bx plus c can sometimes be factored into 2 binomials that will look like this: x plus a number and x plus another number, x plus m and x plus n. Now, to avoid having to do a lot of guessing and checking, it's helpful to look closely for a pattern when multiplying 2 binomials. So let's use what we learned in a previous section in the Looking Ahead chapter, and let's use FOIL to multiply these and see what we notice between all 3 of these examples. Okay, so here, when we multiply the first, that is x times x, which is x squared. The outer will give us 3x. Inner is 2x. And last is 6. And of course we combine like terms to get x squared plus 5x plus 6. Here the first gives us x squared, the outer gives us minus x, inner is minus 4x, and last is plus 4. Combine the 2 like terms here to get x squared minus 5x plus 4. And then this last one, the first, will give us x squared. The outer will give us negative 5x. The inner will give you plus 3x. And the last gives us minus 15. Combine the 2 middle terms to get x squared minus 2x. Oops, minus 15. Okay, there we go. Okay, so now if we look very closely at the 2 numbers we started with and the 2 numbers in the trinomial we end with, you might start to notice a pattern. So notice here, 2 plus 3 is equal to 5. And then 2 times 3 is equal to 6. Similarly, here our original numbers were negative 4 and negative 1. So negative 4 plus negative 1, when we add those together, we get negative 5. And then if we multiply those two, negative 4 times negative 1 will give us positive 4. And the last one, our original numbers were plus 3 and minus 5. So when we add those, 3 plus negative 5 we'll get negative 2. And then when we multiply 3 times negative 5, we get negative 15. So now you should be able to see the pattern between those numbers. What we're looking for here is for these two numbers to have a sum equal to this number here and a product equal to that number there. So in general, when factoring a trinomial of the form x squared plus bx plus c, we must find two numbers whose product is, when we multiply them, it should give us the last number. So that would be the c, so whose product is c, and whose sum, that's what we get when we add them. So like here, the sum gave us this number, here the sum gave us that number, here the sum gave us this number. So that would be the b here, whose sum is b. Okay. So let's see if we can factor these. So for the first one, you have x squared plus 7x plus 10. Well, we want to look at the last number because this is much more limiting. Think about it this way. There are lots of pairs of numbers that add to equal 7. That's not very helpful. But there's only a very limited list of numbers that multiply to equal 10. In fact, there's two pairs of numbers. There's 1 and 10, and there's 2 and 5. Now here, when I multiply both pairs of numbers here, I get 10. But when I add 1 plus 10, I get 11, which is not 7. But when I add 2 plus 5, I do get 7. So this is not the right set of numbers. This one is the right set of numbers. So then our two factors are, we'll start with x. This is plus 2. And this one is plus 5. Okay, let's do something similar on b. So here, we notice that we run into a middle term that is negative. So if I want two numbers that have a product of positive 12, but a sum of negative 8, that will tell us, since this number is positive, the product has to be positive, which means that the two numbers have to have the same sign. But in order for this sum to be negative, the two numbers, if they have the same sign, both have to be negative. So we want pairs of numbers that multiply to equal 12, and they'll be pairs of negative numbers, and they need to have a sum of negative 8. So let's see what we have. We have negative 1 and negative 12. Nope, those have a sum of negative 13. That's not what we want. We have negative 2 and negative 6, and those have a sum of, oh, negative 8. So that's the set of numbers we want, and those give us our two factors. So here's minus 2, and here's minus 6. Okay, for C, we're now looking for numbers that multiply to equal negative 8. So in order for the product to be negative, the two numbers have to have different signs. And we want them to add to equal 2. So we could start with 1 and 8. And remember, one of these has to be negative. The larger number will always have to carry this sign, because when you add two numbers that are different signs, remember that you keep the sign of the larger number. So in this case, the 8 would have to be positive, the 1 would have to be negative. But these do not add to positive 2. So we go to the next set of numbers, 2 and 4. And again, the larger one will be positive, the smaller one negative. And here, these do add to positive 2. So we have our two factors. One of them is negative 2, so that's x minus 2. And the other one is 4, so that's x plus 4. Okay. And for this one, so we want factors of 7 that add to equal 1. So numbers that multiply by or multiply to equal 7 would be 1 and 7, which don't have a sum of 1. 1 plus 7 is 8. But then 7 is prime, so there are no other number pairs that multiply to equal 7. So this is a trinomial that is not factorable. Since there is no pair of numbers that fits the right criteria here, there's no way to factor this at all. Okay, there are 4 try it yourself problems at the bottom for you to do on your own. So pause the video and factor each one of those, and when you're ready to check your answers, press play. Okay, for A, you should have gotten x plus 1 times x plus 3. B is not factorable. C is x minus 3 times x plus 4. And D is x minus 1 times x minus 9. All right, let's look at the last example on the back page. So this says the platform on which table tennis is played has an area that can be represented by y squared minus 2y minus 3. What are the dimensions of the platform in terms of y? Okay, so if you remember how we find, and of course we're talking about a table or a platform on which table tennis is played, so we know this is some sort of a rectangle. If you recall, to find the area of a rectangle, we would need to multiply length times width. Area equals length times width. So whatever the dimensions of the platforms are, when I multiply the two things, they should give me this polynomial. Well, so basically what we want are two things in terms of y that multiply to equal this. So really what we want is to factor this polynomial. So y squared minus 2y minus 3 is what we want to factor. So now we're looking again for factors or numbers that multiply to equal negative 3 and add to equal negative 2. So we do know that because the last term is negative, in order to have a negative product, one of the numbers must be negative, and just one, not both. So we know we have one negative number, one positive number. And the only things you can multiply to equal 3 are 1 and 3. But to get negative 2 here, if I made the 1 negative, 3 and negative 1 would give me positive 2. So I'm going to need to make the 3 negative. Okay. So if the 3 is the negative factor, this is y minus 3. And 1 is a positive factor, this is y plus 1. So the dimensions of the platform in terms of y are y minus 3 and y plus 1. Okay, part B says, if y equals 8 feet, what is the total platform area? Well, if I know that y is equal to 8 feet, I have two expressions in terms of y that give me the dimensions of the platform, and I can then use that to find the area. So if y is 8 feet, then y minus 3 would be 8 minus 3, which is equal to 5 feet, and then y plus 1 would be 8 plus 1, which is 9 feet. And if we want the total platform area, we just multiply length times width. So the area would be 5 times 9, or just 45. And so we're talking about area, and we know these are in feet. Let's leave that as square feet. Okay. Those are two try-it-yourself problems at the bottom of the page for you to do on your own. So press play, work through those two problems. When you're ready to check your answer, or press pause, work through the two problems, and when you're ready to check your answers, press play. Okay, for part A, the dimensions of the base, I should get x plus 4 and x plus 5. And then for part B, if x equals 10 feet, the dimensions would be 14 feet and 15 feet. But then to answer the second question, how much area is being designated to store it, if these are the two dimensions, the area you should have gotten should have been 210 square feet. All right, and that is it for Looking Ahead Section 8, which is the last section in the textbook. Yay!